Okay, Assalamualaikum warahmatullahi taala wabarakatuh. Bismillahirrahmanirrahim. Kita continue dengan chapter 3 ya. Atomic spectroscopy based on flame atomization. So we will focus only on flame because actually atomization ada banyak lagi cara. Ada plasma, ada flame, ada graphite furnace, but we just focus on flame. And the subtopic that we will discuss is the theory or the principle of the AAS, a bit of instrumentation and also application of the AAS. Okay, again the same thing, flame atomic absorption spectroscopy. So this lecture will cover fundamental principle or the theory. Flame AAS, we will discuss sample atomization using flame atomizer. And since we discuss about flame, we look at the property of flame. Okay, so that is the second subtopic of the theory. The third subtopic is instrumentation for flame AAS. So we look at the radiation source, line source, and a specific discussion about source modulation. So what is the source modulation? Nanti kita tengok what is actually source modulation. Then we will discuss about interference and also application, and a bit about detection, limit and accuracy. Again, this is my MIP that helped me to explain based on the subtopic, things that need to know, that we need to understand for each subtopic. So you boleh tengok So this is the principle, tak ada apa sangat. For flame AAS, we look at the sample atomization process, flame atomizer and also property of flame. So dalam video ni saya cuba habiskan untuk subtopik 1 dengan subtopik 2 dulu. Okay. Kalau tak sempat maybe kita tengok 1 je dulu. Okay, so let's go. Look at the theory. As an introduction, again we look at the definition of atom. Atom are the simplest and the purest form of matter that cannot rotate or vibrate as a molecule does. Because atom ni only contain electron, proton and neutron. So dia tak boleh vibrate, dia tak boleh ni. Electron can only undergoes transition daripada lower energy level to higher energy level. Kalau kita boleh lukiskan, kalau atom dia ada E1, E2 dan seterusnya. This is for atom. For molecule, we have a small energy level which is known as vibration and rotation level. Kat sini. Okay. Macam itulah, lebih kurang susah saya nak lukis gunakan mouse ni. So this is for molecule. Jadi atom hanya undergoes transition daripada lower energy level to higher energy level and go back to the lower energy level. So kalau dia jump ke sini, undergoes emission. So this is absorption, this is absorption, this is emission. Naik absorption, excited, require absorption of energy, go down back to the lower energy level will emit radiation. Okay, so atoms only undergoes electronic transition when energy is absorbed. Dia hanya yang inilah, dia tak ada rotational and the vibrational level like in the molecule. So because the electronic transition are discrete or quantized, so that's why in atomic spectroscopy we will get a line spectra, not like in molecule yang ada banyak sangat peak, so kita dapat band ataupun continuous spectra. And the application of atomic spectroscopy is normally used in the analysis of heavy metal contamination in environmental sample. environmental sample can be in air, water, yeah. So that is two most frequent sample being used with AAS, yeah. Example of heavy metal are the transition metal, and sometimes metalloids pun boleh juga, lanthanide and actinides also can be analysed using AAS. Metal impurities in pharmaceutical sample also can be detected using AAS, yeah, can be analysed using AAS. Okay, so that is the application of atomic absorption spectroscopy or atomic spectroscopy. Yeah, not only absorption, emission pun boleh juga. Tapi kita hanya belajar absorption. Yeah. So, three techniques or methods included in atomic spectroscopy. So, we have three methods. Even though all is atomic spectroscopy, but we can have atomic absorption spectroscopy, atomic emission spectroscopy, and atomic fluorescence spectroscopy. So absorption, in absorption spectroscopy, the instrument will measure the absorption, yeah, absorption, nanti kita akan discuss in the next slide. In atomic emission, the instrument will only measure emission, and in atomic fluorescence, the instrument measure reflectance, yeah. So semua tu absorb, emit and reflectance tu kita dah tengok dah dalam chapter 1 dulu. Apa beza ketiga-tiga interaction of sample with the electromagnetic radiation. So, okay, then AAS and AES are used to determine the concentration of elements in the solution. Yeah? So normally AAS dengan AES is used for quantitative. Yeah? To determine the concentration means that the quantitative analysis. Okay. Okay. This one again for atomic absorption dengan atomic emission. For atomic absorption, the instrument will measure absorbance, of course. Where we can get the absorbance from this equation, negative log P over P naught. So remember P and P naught. P is the transmitted radiation. P naught is the incident radiation that comes from the radiation source. Yeah. Tengok balik chapter 1, saya lupa pula nak letak dekat sini. Ini saya just nak bezakan antara absorption dengan emission. Yeah. And from the absorbance, we can calculate the concentration using this Beer's law. Okay. But for atomic emission spectroscopy, the instrument will measure the intensity of the emitted radiation. Okay. So the emitted radiation that will give us the concentration, yeah, using this equation. So what is the difference between absorbance dengan transmittant? So this is absorbance. How much being absorbed is equal to how much being transmitted. Bila dia excited, then go back to the lower energy level, dia akan absorb then emit the same amount of energy, because energy is quantized for each electronic level, electronic transition level. Okay, so macam itulah dalam absorption, kita boleh calculate the concentration based on this equation. In emission spectroscopy pun, kita boleh calculate the concentration using this equation. Yeah. K is the constant. Yeah. C is the concentration of the sample. Okay, sama juga yang ni saya tak tulis sebab kita dah tengok dah yang ni dalam Beer's law. Ya. C is the concentration of the sample. B is the path length of the sample holder. Tapi dalam kes ni, B is the path length of the flame. Ya. Panjang mana api yang ada dalam instrumen tu. Epsilon is the molarity, molar absorptivity constant. Ya. Constant juga. Okay, principle of flame AAS. First, in the flame AAS spectrometer, in the instrument, the sample will be aspirated in the form of aerosol into flame using nebulizer. This one actually is good kalau saya tunjukkan dulu gambar flame, ya. Okay, sorry, gambar instrument. So this is our sample. Sample is normally in the form of liquid. Kita letakkan di dalam beaker. Kemudian it will be aspirated in to the instrument. Aspirate mean dia akan suck in, ya. Dia sedut. Yang ni tube, ya. Yang ni fine capillary tube. Untuk sedut masuk sampel kita into this burner head. Kemudian dalam ni ada nebulizer, this is air, this is fuel, nak masuklah untuk hidupkan api ni. So the nebulizer will nebulize. Nebulizer, kalau kamu tahu, pernah tengok kan orang yang ada asma tu, dia selalu gunakan ubat which is called nebulizer. So dia spraykan ubat tu masuk dalam dia punya mulut. So the same with this instrument. Nebulizer is used to nebulize or to spray this solution into fine mist. Jadikan dia small droplet of water. Okay. Kemudian bila dia dah nebulize, dia akan undergo atomization process. So atomization process pun kita akan discuss detail nanti. And the atom will go to this flame. So flame ni lah yang kita akan discuss detail dalam flame atomic spectroscopy ni. And of course, dalam spectroscopy, we must have radiation source, sample, monochromator, detector, and readout. Okay, and back to our slide tadi. Okay, sekejap ya. Okay, the principle of AAS. So the principle of flame AAS, first the sample is aspirated in the form of aerosol into flame using nebulizer. Dia gunakan tube tadi tu, kemudian masukkan dalam nebulizer. Nebulizer spray dia jadi fine mist, then masuk dalam flame. In the flame, the liquid or solvent is evaporated while the metal vaporizes as an atom. Okay. So dalam flame tu, liquid yang daripada bulk solution tadi tu, dia akan remove lah. Sebab suhu panas kan, dia akan keringkan solvent tu, tinggal sampel kita in the form of solid. Okay, ataupun nanti kita akan tengok untuk jadikan dia atom. Then the flame contain atoms of a metal. Flame tadi tu dia alignkan dengan radiation source dia letakkan supaya align dengan radiation source, supaya bila radiation source tu lalu kena pada atom of our sample tu. And the flame is lined up in the beam of light of the appropriate wavelength. Ini macam saya mention sebelum ni, untuk AAS setiap instrumen, setiap sampel tu kena ada lampu dia. Kalau kamu nak analyze copper, kamu kena ada lampu copper. Okay. Light is absorbed by atom of analyte. So bila dia absorb, the instrument will measure the absorbance tu, from P and P naught. Okay, then we will get the absorbance. The flame in the form of thermal energy cause the atom to undergo transition from ground state to the first excited state. And when the atom make their transition, they absorb radiation from radiation source, light from the beam, or from the radiation source of a particular wavelength that produced by special source made from the element, which is our radiation source lah, HCl dengan EDL. So HCl dengan EDL ni dia spesifik. Kalau kamu nak, saya cakap tadi, kalau nak measure light, mesti guna lampu LED. And the more concentrated the solution, the more light energy is absorbed. This one sama macam UV. Kalau banyak sampel kamu, tinggilah absorption dia. Tinggilah dia punya peak tu. Okay. The lamp again sama juga. The lamp must be aligned perfectly to the hottest part of the flame. Mesti pada bahagian api tu yang paling panas. Kenapa? Nanti kita akan discuss detail. And it will travel to the detector. And detector measure the intensity of the beam of light. And the intensity of beam will kalau ada absorption, so we get